Megan and Whitney are on.
Yes, we're
Okay,
here.
good. Okay, I
I
just
think
didn't see it 'cause I'm on my phone.
Cynthia said she dropped the class, so
Oh,
she
okay.
wasn't planning on us inviting her, right?
I don't think so.
I don't think
Since she
so.
said she dropped it. Okay. All right. Did we want to try and do both lessons, or are we going to meet again on Thursday?
For me, it'll be great if we meet on Thursday because now I don't have a lot of time.
Okay.
I'm
Meeting
good
to
with meeting
attend
on
like
Thursday
right
as
now.
well.
Me too.
I would much rather meet on Thursday than try to do both of them. Okay, great. So lesson 6.
Okay, go.
Did you guys have any questions or?
I don't.
Not that I can think
I'm
of
just
off
trying
the
to
top
get
of my
my
head.
computer to work.
Okay. Shall we just go do the quiz then?
Yeah, let's do it.
Okay. Where am I?
My computer's not pulling up, so I'm trying, but
Okay.
we'll see.
So are we still being recorded, I guess, even though we're just in the quiz?
Yeah.
Okay. Group meeting quiz. Okay.
Is anyone else struggling with the text?
With the
No,
book?
I mean,
I don't like the layout of it.
oh,
Oh, yeah, I've had to print some of it just because I can't
Right.
keep going back and forth.
Yeah.
It's hard to follow. Okay.
yeah.
I'm just going to mark these first 2 questions before I forget.
Right.
I try to do the homework as long as I read the book so I can, because usually they have an order how the questions go through. So I think that helps me
Right.
out with reading.
Yeah. Okay. Okay, so we know the rules about calculating to the 3 decimal places. Do not round until your calculation is complete. Oh, Whitney, by the way, I figured out what we did wrong on that last one.
Oh, what did we do wrong?
So when it's under 50%, you're supposed to use the negative z-score.
The negative z-score, yeah.
And we didn't.
That makes sense.
So we were a few points off. Okay. So when you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed? It would be right skewed, right?
What did n equal?
N is only 5. So n equals 5. So I think it would still be right skewed.
Yeah, I would
Yeah.
think so too. Because
It
it's a
doesn't
very
have to,
small sample.
yeah, it would have to be like over 30 to get it to be normal.
Right.
Okay. Question 4, I'll read it. When you're taking a sample of size n 100, what is the shape of the distribution of means histogram when the parent population is right skewed?
Isn't it normal?
Yeah, I put normal.
Yes.
I think normal because of the sample size, right?
Yeah.
Yeah.
Yes.
That's that, whatever that rule is called. Continuing limit
Isn't it
theorem
the
or
large
whatever.
theory?
The central
Yeah.
limit theorem.
Yeah, central limit theorem. Okay.
Okay, question 5. When you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is normally distributed?
Still, it'd be normal.
Still normal.
Yeah.
If the parent population's normal, then it's normal.
Yes.
And you don't have this, right, Megan? So it's my turn.
Yeah, sorry.
That's
I don't
okay.
know what my internet's doing.
When you are taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is normally distributed? Normal.
Normal also.
This seems too easy.
I know, that's what I was thinking too.
So I hope we don't have them all wrong. All right.
Oh, my turn. Okay, when would the distribution of means be normally distributed? Choose all the correct responses. Data are drawn from a population that is normally distributed. Oh, you want me to read all of them or just?
Well, I think that first one's true.
I agree.
Data are drawn from a population that is normally distributed and the sample size is small. I guess we should read them because Megan can't see them.
Okay.
Right.
Okay, data are drawn from a population that is normally distributed and the sample size is small. Second one is data are
No.
drawn from a population that is normally distributed and the sample size is large. I think the second one is right.
The first one is right too because it's normally distributed. So
Oh, yeah.
the distribution of means is going to be normally distributed. Right?
So when is it not
Right.
normal distributed then?
So normally distributed is the bell-shaped one.
Yeah.
So it's if parent population is normal or if parent population is not normal, will be approximate sample size is large enough.
Wait, what question are you on?
Okay.
Oh,
No,
yeah.
she's just reading off the text.
Oh, okay.
I'm just reading off the text when it of what
But
it's
if-
saying when it.
If the sample size is small, it's still going to be normally distributed if the population is normally
If the
distributed.
parent population is normally distributed.
Okay.
Yeah.
Right.
Yeah, because the third one says data are drawn from a population that is rescued and the sample size is small.
That one's not going to be normal.
Right.
It's going to be right skewed.
And the fourth one says data are drawn from a population that is right skewed and the sample size is large. That's correct.
That's correct.
Okay, so those
So
three-
1, 2, and 4 are correct, right?
right.
Yes.
Okay.
Okay, question 8. Which of the following gives the best explanation of the social spectrum? Ooh. So if the parent population from which the data are drawn is normally distributed, then the sample mean, oh, I can't even remember. What's the X over the line? What's that sign called?
That's the sample mean.
That's just the sample mean.
That's sample mean. Okay, we'll follow a normal distribution. For bell-shaped data, approximately 68% of the data will be within one standard deviation of the mean, about 95% of the data within two standard deviations of the mean, and approximately 97% of the data will be within 3 standard deviations of the mean. If the sample size is large, the sample mean will be close to the population mean. If the sample size is large, then the shape of the distribution of sample means will be approximately normal.
Is that last
I
one
think
the
the
law of large
first one.
numbers?
I think so. Let's see.
I think it's the first one for me.
Yeah, because the other one is 68, 95.
Yeah, that's just the rule, the 60/90.
Yeah,
Yeah, I think it's the first one.
I think it's the first one also. So I think the last two have to do with that law of large numbers.
Yes.
So which one is it?
We think it's the first one.
So if
The
the
parent
parent,
population from which the data are drawn is normally distributed, then the sample mean will follow a normal distribution.
Yeah.
Okay.
Question number 9.
okay. So moving on to question number 9 here. So it says use the following information to answer the next 4 questions. Let X be a
You still there, Whitney?
She just dropped on the call.
Oh. Darn. Do I need to invite her again?
Try inviting her again. I'll read it for now. I mean, when you try, we don't answer until maybe she joins again, but I'll read it.
Okay.
It says, use the following information to answer the next 4 questions. Let X be a random variable with population mean equals 10 and population standard deviation sigma equals 6. Suppose a sample size of n equals 36 is drawn from this population. The question is, what is the mean of
Oh, I can't find my quiz. Oh, here it is. Okay. All right, is Whitney back?
Yeah, sorry, my dad was calling me and it kicked me out.
Oh.
So isn't number 9? Isn't it 10?
In a populace, suppose the sample size of n equals 36. Oh man, is that going to kick me out too when someone does something?
Hopefully not.
Okay.
So what's the question for number 9?
So what is the population mean is 10. The standard deviation is 6. What is the mean of the distribution of sample means?
So isn't the mean for this one, isn't it 10?
I forgot how to figure it out. How did you figure it out, Whitney?
So
Oh, go ahead, Megan.
Oh, Megan, sorry.
so we're trying to find the standard deviation of the sample means.
What is the mean of the distribution of sample means?
Oh, yeah. I think you're right. It would be 10 because it's going to be close to the population mean.
Yes, that's what I'm thinking. Based off the examples I watched in the video.
Right.
So in my notes it says standard deviation of sample means. That's what we're looking for, right?
We're looking for the mean of the distribution of sample means.
Oh, okay.
Oh, Daniel said, try again. I have to go, but those questions are easy.
Okay.
So it's not 10?
I think it's 10, but I could be wrong.
Well, let's go with 10, and then if it's wrong, we can figure out what we did wrong.
Okay, so question 10 is, what is the standard deviation of the distribution of sample means?
Well, I have that.
So this one is the 6 over the square root of 36, right?
So
Yeah.
it's going to be x minus 10. Wait, the n is 36. I'm getting all these formulas so confused.
So what's our standard deviation?
Our standard deviation is 6.
So it'd be the 6 over the square root of 36.
Which is 1, right? Is that what you got?
Yeah, because 6 divided by 6 is 1.
Yeah.
I think I'm making it too complicated trying to figure out z-scores and stuff.
Oh.
So this is 1, right?
Yeah.
So, yeah.
Okay. Okay, question 11. Regardless of the distribution of the population, if the sample size is large and is greater than 30, what would be the shape distribution of the sample mean? It would be normal, right?
I believe so.
Okay. What theorem would justify your response to that last question?
Is it the law of large numbers? No, I don't know. Or
I
is it
think it's the law of large numbers, but I'm getting those two mixed up now, I think.
Me too.
Can you
Let
read
me
it one
look
more
at the-
time?
What
What
theorem?
theorem? Oh, sorry, go ahead.
Sorry, you're good. What theorem would justify your response to the last question?
I know. Can you? Sorry. Can you
they
read the
want
last
before?
question? Yeah.
That one is, regardless of the distribution of the population, if the sample size is large, n is greater than 30, what would be the shape distribution of the distribution of the sample mean?
Well, law of large numbers, I wrote for it says if sample size is large, then sample mean will typically be close to the population mean.
Okay.
Yeah. The central limit theorem is,
I would say it's the central limit theorem.
it
'Cause
works
in
for
my
any
notes-
population where the standard deviation is defined. In other words, it will work for any distribution you find in the world. Yeah, central limit theorem will assure that the distribution of sample means will be approximately normal.
So it's the central limit theorem?
I think it is. I'm trying to read. Did they actually give us a definition of this central limit theorem?
At the very end, I'm trying to get it. So it says the distribution of a sample mean is normal when X is normally distributed or when our sample size is large.
Okay.
And then the law of large numbers, it says states that as the sample size n gets larger, the sample mean x will get closer to the population mean, the
Yeah.
u, or whatever it is.
Okay, then it's the central limit theorem.
Yeah, that's what I
Yeah.
think too.
Okay. Okay. Is that the last question?
Yes.
Okay. Do you want me to? Do you want to turn it in, or do you want me to, Whitney?
Either way is fine.
Okay, I'll go ahead and do it, and then that way we won't both submit the wrong answers. And we can try again before you submit it. Okay.
Yeah.
I'm going to submit it.
Is this quiz due tonight or is it due tomorrow?
It's due tonight.
But it looks like it's open till tomorrow.
Right. I think it is open till tomorrow. Okay, so we got question 8 wrong.
Question 8. That is, which of the following gives the best explanation of the central limit theorem?
So I think we maybe goofed up on that one. We were
Yes.
maybe thinking of the law of large numbers. Well, obviously we goofed up, but
Oops. So let's see.
so we put if the parent population from which the data are drawn is normally distributed, then the sample mean will follow a normal distribution.
And based on the definition that I just read, that would be the law of large numbers.
Right.
Okay.
So
So
I
is
think
it-
we got those two mixed up.
Do you think it's if the sample size is large, the shape of the distribution of sample means will be approximately normal?
Yes.
Okay.
Yeah, I think that's the right one. So that's going to be number 4, right?
Yes.
Okay. So, sorry, let me see. We got, and that is the only one we got wrong.
Awesome.
Nice.
Nice.
Good
Okay.
job.
So, we still got an A. I'm wondering if I want to retake it or not. Like, is it worth going through it all again? No, actually, we didn't. It's 92.86%.
I'm going to try to do it from my phone.
Oh, that's a good idea.
That's
Okay.
scary.
I'm just going to write all the answers down again and take it again.
If you want, I can tell you
Oh.
while it's out.
Will you put that in and see if it's the right answer, Whitney, before we
Yes,
do
I
it?
did. And it is the right answer.
It is. Number 4 is the right answer. Thank
Yes.
you.
Okay.
So
How do I
3
even find
is skewed right. Well, these first ones were pretty easy.
Yes.
I guess if you understood it, if you didn't understand, it wouldn't be easy.
That's true.
I even was able to follow just with not even having it in front of me.
Yeah. So question 8 is sample size. Question 8, the answer is if the sample size is large, the shape of the distribution of sample will be approximately normal, right?
Correct.
Okay. Okay, and 9 is 10. 7 is 1.
So 3 was right skewed.
3 was right skewed, 4 was normal, 5 was normal, 6 is normal.
7 is 1, 2, 4.
1, 2, and 4, yeah.
8 is 4. 9 is 10.
Uh-huh.
10 is 1.
Yes.
Yes.
11 is normal, and 12 is central limit theorem.
Yes. Okay. So Thursday at 6.
Sounds
Yep.
good.
Okay. Thanks,
All right.
guys. I'll go
Thank
ahead
you.
and
Thank you.
get
See you
this
Thursday.
posted. See you Thursday.
See ya.
Ah. What did I do with my link?